Unit 8, Day 4, Equations of Lines of Best Fit. So recall that the line of best fit was a tool we used in data management. Remember that this line was a line that we added to a scatter plot to help us make predictions called interpolation and extrapolation. So in the picture below, the line of best fit is that blue line. It's that line that goes through as many points as you can and has an equal amount of points on either side of the line. So now with our knowledge of linear equations, we could actually determine the equations of these lines of best fit algebraically. So determine the equation of the line of best fit of the following table algebraically. So the first thing we want to do is plot all of these points onto the graph. So as you can see, I have drawn the graph and plotted all the points. So our next step is to draw in the line of best fit. Remember to try and go through as many points as you can, as well as having an equal number of points on either side of the line. So now to calculate the equation of the line of best fit, we need to calculate the slope. So I'm going to pick 2 points that the line goes through. So this point and this point. I'm going to calculate my slope. So my y2, so this is going to be my second point, and this is going to be my first point. So my y2 minus y1 is going to be 10 minus 6, and my x2 minus my x1 is going to be 8 minus 10. As such, we are going to get 4 over negative 2, or just negative 2 as my slope. Now I'm going to use this slope and a point and put it into my slope point intercept and put it into my slope point form. So the point I'm going to choose is going to be 10, 6. So now I'll distribute the slope. And finally, y equals negative 2x plus 26. And this is the equation of the line of best fit. Example 2. A basketball coach recorded the amount of time each player played and how many points the players scored in one game. A. Determine the equation of the line of best fit algebraically. So the first thing we need to do is plot all of the points. So I've plotted the points and drawn my line of best fit. I've done the best job I can to go through as many points as possible and have an equal spread of dots on either side of the line. So now let's calculate the slope using these 2 points because the line passes through them. So slope is equal to y2 minus y1 over x2 minus x1. So this will be my second point and this will be my first point. So y2 minus y1, so 8 minus 2, and x2 minus x1 is 15 minus 5. So 6 over 10. 3 over 5 is my slope. Now I'm going to use my slope point form to get the final equation. So y is equal to 3 over 5 x, and I'm going to use this point. So the point is 15 and 8. Now we distribute the slope inside the brackets. And now we need to convert these into fractions with the same base before we can add them. And we have our final equation right here. So this equation tells us how many points they will score, which is y, for any given amount of time, which is x. Part B, predict how long a player would have to play in order to score 5 points. So we plug in 5 for y, because y represents the amount of points, and we solve for x, which is the time. First thing we need to do is bring the 1 to the other side. So we add 1 to both sides. Now we can multiply both sides by 5. And then finally we need to divide both sides by 3. Therefore, in order for a player to score 5 points, they must play for 10 minutes.